So these are notes on molarity and dilutions. It's 16.2 in your book. If you still need some review on the vocabulary, then I would look at 16.1. And then if you want to go a little further into some stuff that we're not really going to get into, but I find very interesting, there's a concept called colligative properties, and that's later in chapter 16. And that has to do with why, for example, putting salt on ice causes the ice to melt. It doesn't actually cause the ice to melt. What it does is it lowers the freezing point of water. Or why adding salt to water on the stove causes the water to boil at a higher temperature. And those are called colligative properties. And as I said, we're not going to really get into that in detail, but I find it fascinating. So for those of you who kind of want a little more and want to go further, you would have that. So let's look at concentration of solutions. And this is going to be a little bit of review. And so those of you who don't need it can kind of go through this really quickly. Those of you who want it can go through a little more slowly. So as we've talked about, molarity is capital letter M, moles of solute per liter of solution. So moles over volume, right? Liter is a volume measurement. And so, for example, if we're setting up a problem that is, what is the mass of a sugar cube, sugar being C12H22O11, that results in a 0.033 molar sugar solution after being dissolved in 350 milliliters of hot water. Go ahead and pause the video, set that up so you can see how you might do that. And then you can check the answer. So you would set it up like this. It's exactly the same as we've been doing it. Don't try to make this two separate problems. So I always like to start with the number that is only one unit. So we've got molarity here, but remember molarity is moles per liter versus 350 milliliters is just one unit. It's just milliliters. So I'm going to take my 350 milliliters, and first I'm going to convert that to liters, 1 liter over 1,000 milliliters. So my mils cancel. Then I'm going to say, now I'm going to put in my molarity, 0.033 moles of sugar over 1 liter of solution. And you could have written like 350 milliliters of solution and 1 liter of solution over 1,000 milliliters of solution. I didn't, just because that would have made the font really small. And so then I know that 1 mole of sugar of C12H22O11, that's sucrose, is 342.2965 grams. So for those of you who have been miscalculating molar mass, you might want to actually check that. So my moles of sugar cancel, and I'm left with my grams. I have 2 sig figs from this 350 milliliters. The 0 isn't significant. And also from the 0.033. And so that ends up, it's something like 3.95, which then you need to round to 4.0. And so that would be 4.0 grams, 4 grams of sugar in 350 milliliters of hot water, which is the average cup of hot water. And you get a 0.033 molar sugar solution. So there are more of those in your book, and obviously that's what the homework's on. So now let's get a new concept. And so we're going to look at making dilutions, so diluting substances. And we're actually going to do a lab on this, and you're actually going to have to do this. So a more dilute solution has a lower concentration, a lower molarity. And so the opposite of a dilute solution is a concentrated solution. And so again, molarity, M, is moles of solute, which are moles, over liters of solution. And so we're going to call that V for volume. And so we can rearrange this. We can multiply both sides by volume, and we would get the molarity, M, times liters of solution, V, equals the moles of solute, moles. And so this is just looking at the exact same equation, but in a different way. I've multiplied both sides by liters. And we can abbreviate that to M times V equals moles. Okay, so we're going to obviously use this concept. That's why I'm setting it up this way. When you're diluting a substance, you need to add more solvent. And we'll get to this in parentheses in a second. So to make a solution more dilute, you have fewer moles of solute, right? Well, once you've added a solute, you can't take it away. So I want you to think about, you've added salt to soup and you've made it too salty. you can't physically take out the salt at that point. What you need to do is add more broth or more water or more whatever so that you have more solution with the same number of moles of salt, right? You haven't changed the moles of salt. What you've done is you've changed the liters of solution. Similarly, if you want to make something more concentrated, it's not salty enough, you can't take out broth, you have to add more salt. So once you have a solution, in order to make it more concentrated or more dilute, you have to add stuff. You can't take stuff out of a solution. It's just physically impossible, right? If you have some coffee, say, and you add sugar, and it's not sweet enough, you want to make the sugar more concentrated, you can't remove coffee without also removing sugar because it's a solution. You need to add more sugar. If it's too sweet, you need to add more coffee. You can't take out sugar that's been dissolved. I mean, I just think about that conceptually. So to dilute a substance, you're going to add more solvent, but the number of moles of solute remains the same. So go back to the coffee and sugar example. I add too much sugar, it's too sweet. I'm going to add more coffee to that to dilute the sugar, but I haven't changed the amount of sugar, I've changed the liters of my solution, the volume, meaning the moles here is the same. So if I have a solution where I have diluted it, so I take a starting solution, I then dilute it, the number of moles stays the same. So I would have two equations, moles times, molarity times volume equals moles, where the moles are the same. So I can set those moles equal to one another, meaning I can set my two equations equal to one another. So I get this equation, M1V1, so the molarity of my first solution and the volume of my first solution equals the molarity of my second solution times the volume of my second solution, or M1V1 equals M2V2, because the moles are equal in both of these. I haven't changed the moles of my substance. I've just changed the volume and the molarity. So let's take an example of that. So an M1V1 equals M2V2 example. You have 300 milliliters of a 1.0 molar solution. How much water must be added to make it a 0.60 molar solution, so more dilute, but same number of moles? So the first thing I need to do is set up my equation. So my M1 is 0.300 liters. I'm going to assume by now you can convert that in your head. My volume is 1.0 molar, right? My V1. My M2, my second molarity that I'm going to end up with, is 0.60 molar. It's my V2 that I want to know. So I'm going to set that up this way. Actually, pause it. I mean, at this point you've seen the equation, but go ahead, pause it, set it up, solve for it, and then see if your answer is right. So 0.300 liters times 1 molar equals 0.660 molar times V2. So I'm going to divide both sides by my 600 molar, or 0.600 molar. So I get 0.3 liters times 1 molar divided by 0.6 molars. Notice my molar here, those are going to cancel out, so I end up with liters as my unit, and that is V2. And that, if I solve for it, is 0.5 liters. Now, be really clear though. So 0.5 liters, just, you know, to bring this back to what we started with, is 500 milliliters. But you're not actually adding 500 milliliters. The question is, what must be added? This is the volume of your solution at 0.6 molar. So in order to find out how much you need to add, think about that quickly, you would say, I'm going to take my 0.5 liters minus my 0.3 liters, right? I already have 300 milliliters. I need to make it 500 milliliters, meaning I need to add 0.2 liters or 200 milliliters of water. So I take my 300 mils of a 1.0 solution, I add 200 mils. Now I have 500 mils of a 0.6 molar solution. So we're going to do some of those problems in class, but then you're actually going to do a lab where you need to make dilutions. So it's important to understand what it is you're doing. Please make sure to ask questions in class or online. And then you can also read through your lab so you now understand what you're doing.